This is the screencast for section 8.2, example 2, applying a stronger form of L'Hopital's rule. So we're going to do the same exact thing we did before. We're going to evaluate the limit as x approaches 0 of that big old mess. So algebraically, can I cancel anything out? No. I think I'm going to have to use L'Hopital's rule here. Just to try and plug in 0, I get 0 over 0, which is more evidence that L'Hopital's rule would be a good route to choose. So I have the limit as x approaches 0 of the derivative of the numerator over the derivative of the denominator. Now let's plug in 0, but again, I get 0 over 0, so let's repeat the process. So that's why this stronger form really comes into play. If I had a number in here, if I had already plugged in the number, I would have to, and I took the derivative, that would be 0. So the fact that we still have x's in here lets us use L'Hopital's rule in repetition. So now I have the limit of the derivative of the derivative of the numerator and the derivative of the denominator. Now I can plug in 0, and I get negative 1/4 over 2, which is just negative 1/8. Now try problem number 5, says apply the stronger form of L'Hopital's rule to find the limit. Again, I always recommend to keep x in there as long as possible. So first of all, I'm going to try plugging in 0, see if I even need to do anything with this. And yeah, I get the indeterminate form 0 over 0. So instead, I'm going to take the limit as x approaches 0 and the derivative of the numerator over the derivative of the denominator. L'Hopital's rule says that that's going to be the same. So I plug in 0, but yet again, I get 0 over 0. So I got to use L'Hopital's rule again. The limit as x approaches 0 of now the cosine of x over 2. Now I can plug in 0 and I get 1/2. So if I were to graph the function 1 minus cosine of x over x squared, the limit of the y values as x approaches 0 is 1/2. Basically the point 0, 1/2 is the removable discontinuity there.